Scientists have long searched for signs of life on Mars. But what if we've been asking the wrong question all along? Instead of asking if life ever existed on Mars, a growing number of researchers are now wondering, did it start there first? And even more shocking, could Earth's life forms be Martian immigrants? But here's where it gets really strange. New evidence suggests that the basic building blocks of life may have formed on Mars before Earth was even habitable, and that an asteroid collision may have blasted life-seeding microbes from Mars to our young planet. Stick around, because this theory could completely flip our understanding of where we came from, and it's backed by real planetary science you won't believe. Looking up into the night sky, you see a canvas of ancient light, stars that died billions of years before your first breath, their final whispers only now reaching your eyes. But what if I told you that the story you've been told about life itself is backwards? What if the very ground beneath your feet, this pale blue dot we call home, wasn't the beginning of our cosmic tale, but merely the final chapter of a story that began elsewhere, in the rust-colored deserts of a dying world? Picture this moment. 4.5 billion years ago, when our solar system was nothing more than a swirling disk of cosmic debris, two worlds were taking shape in the Goldilocks zone around our young, violent sun. Earth, a molten hellscape of lava oceans and poisonous skies. And Mars, smaller, cooler, stabilizing faster into something that might, just might, harbor the universe's most precious secret: life. You've been conditioned to think of Mars as the dead planet, the failed experiment, the cautionary tale of what happens when a world loses its atmosphere and surrenders to the cosmic cold. But what if Mars wasn't the failure? What if Mars was the prototype, the beta version, the rough draft of life that would later be perfected here on Earth? What if every cell in your body, every breath you take, every thought passing through your mind right now traces its lineage not to some primordial soup in Earth's ancient oceans, but to the first tentative stirrings of biology in Martian hot springs, billions of years before Earth was even habitable? The evidence is starting to whisper this impossible truth. Deep beneath the Martian surface, robotic explorers have found something that shouldn't exist on a dead world: complex organic molecules, methane signatures that pulse with the rhythms of seasons, geological formations that mirror the bacterial mats found in Earth's most extreme environments. These aren't just rocks. These are breadcrumbs leading us back to a revelation that could rewrite every textbook, challenge every assumption, and force us to confront an uncomfortable reality about our place in the cosmos. Imagine the implications. If life began on Mars, first, then every living thing on Earth, from the smallest bacterium to the largest whale, from the towering redwoods to the intricate neural networks firing in your brain right now, is essentially Martian. You are not an Earthling who dreams of exploring Mars. You are a Martian who has come home. But how could life travel between worlds? How could biology survive the brutal journey through the vacuum of space, the deadly radiation, the bone-crushing impact of planetary collision? The answer lies in one of the most violent and beautiful phenomena in our solar system's history, something scientists call panspermia, the seeding of life from world to world through cosmic catastrophe. 4 billion years ago, Mars was under siege. Massive asteroids, some the size of small moons, were pummeling its surface with apocalyptic force. Each impact didn't just create craters, it created cosmic shotgun blasts, hurling chunks of Martian rock, complete with any microbial passengers they might contain, into the depths of space. Some of these biological refugees found their way to Earth's gravity well, delivering not just rocks, but the seeds of everything that would follow. This isn't science fiction. This is science fact. We've found Martian meteorites in Antarctica, pieces of the red planet that survived the journey through space and the fiery descent through Earth's atmosphere. Inside these ancient time capsules, researchers have discovered structures that look disturbingly like fossilized bacteria, the signatures of life preserved in stone, waiting 4 billion years to tell their story. The timeline aligns perfectly with what we know about early Earth. When our planet was still a hostile wasteland of volcanic fury and asteroid bombardment, Mars had already cooled into a world of flowing rivers, stable lakes, and perhaps even vast oceans. While Earth was still learning how to be a planet, Mars had already mastered the delicate chemistry of life. The red planet had a head start measured not in millions, but in hundreds of millions of years. Consider the poetry of this possibility. Every sunset you've ever watched, every flower that's ever bloomed, every kiss, every tear, every moment of wonder and beauty in the long history of life on Earth. All of it might trace back to microscopic pioneers who began their journey on another world entirely. You are not just stardust, as Carl Sagan famously said. You are Mars dust, shaped by eons of evolution into something capable of looking back across the void and recognizing your cosmic ancestry. The ramifications extend far beyond mere scientific curiosity. If life began on Mars and seeded Earth, then life itself might be far more resilient, far more adventurous, far more determined to survive than we ever imagined. It suggests that biology doesn't just adapt to environments, it transforms them, travels between them, refuses to be contained by the boundaries of single worlds. It means that life, true to its nature, finds a way not just to survive, but to thrive, to spread, to ensure that consciousness and complexity have the chance to emerge wherever conditions allow. This is the question that will haunt you long after you've finished watching this story unfold. If we are the children of Mars, what does that make us? Are we refugees from a dying world, carrying the torch of Martian life to new frontiers? Are we the universe's way of ensuring that the light of consciousness, once kindled, never truly dies? Or are we something else entirely? Cosmic gardeners, destined to seed other worlds the way Mars once seeded ours, continuing an ancient cycle of life, death, and rebirth that stretches across the vast emptiness between the stars? The evidence is mounting, the questions are multiplying, and the implications are staggering. We stand at the threshold of a revelation that could fundamentally alter our understanding of life, consciousness, and our place in the cosmic story. The red planet that has captured our imagination for centuries might not be our destination. It might be our origin, our birthplace, our first home in the endless dark. And if that's true, then everything changes. To understand how life might have begun on Mars before Earth, we must first journey back to the very foundations of existence itself, to a time when the universe was still writing its own rules, still deciding what was possible and what was not. The story begins not with planets or stars, but with something far more fundamental, the delicate dance of chemistry and time that transforms dead matter into living complexity. Picture the early solar system as a cosmic construction site, chaotic and violent beyond imagination. 4.5 billion years ago, our corner of the galaxy was nothing more than a swirling disk of debris, the remnants of ancient stars that had lived, died, and scattered their enriched ashes into the void. This wasn't the orderly, predictable solar system you know today, with planets following neat elliptical paths around a stable sun. This was pandemonium. Chunks of rock the size of continents careening through space, colliding, merging, breaking apart, and colliding again in an endless ballet of creative destruction. But here's where the story becomes fascinating, where the established narrative begins to crack under scrutiny. We've been taught that Earth, being in the perfect habitable zone, not too hot, not too cold, was destined to become life's first garden. Mars, we're told, was too small, too far from the sun, doomed to become a frozen wasteland. This narrative feels comfortable, logical, almost inevitable. But what if our cosmic timing is completely backwards? Consider this. In the early solar system, the sun was significantly dimmer than it is today, roughly 25 to 30% less luminous. This phenomenon, known as the faint young sun paradox, creates a troubling contradiction in our traditional understanding. If the sun was dimmer, then Earth should have been a frozen ice ball, completely inhospitable to life. Mars, despite being farther out, might actually have been in a more favorable position, cool enough to maintain liquid water without the violent volcanic activity that was still reshaping Earth's surface. The timeline of planetary formation tells an even more intriguing story. Mars, being smaller than Earth, cooled and solidified much faster, while Earth was still a molten hellscape, bombarded by massive asteroids in what scientists call the late heavy bombardment. Mars had already developed a stable crust, potentially breathable atmosphere, and most crucially, liquid water. The red planet had what astronomers call a head start. Not just millions of years, but potentially hundreds of millions of years of stable, habitable conditions, while Earth was still learning how to be a planet. This head start becomes even more significant when you understand the delicate requirements for life's emergence. Life isn't just chemistry. It's chemistry with memory, chemistry that can copy itself, chemistry that can evolve and adapt and grow in complexity over time. This process, called abiogenesis, requires not just the right ingredients, but the right conditions sustained over enormous stretches of time. You need liquid water, organic molecules, energy sources, and most importantly, stability. You need time for countless molecular experiments to fail before one finally succeeds. Early Mars provided something that early Earth could not: consistent, stable conditions over geological timescales. While Earth's surface was being repeatedly sterilized by massive impacts, while its atmosphere was being blown away and reformed multiple times, Mars was quietly developing the complex chemistry that might give rise to the first self-replicating molecules. The planet's lower gravity meant that its atmosphere was thicker and more stable in those early days. Its smaller size meant that its internal heat dissipated gradually, creating long-lived hydrothermal systems, underwater hot springs that might have served as the perfect incubators for life's first tentative experiments. But here's where our understanding becomes truly unsettling. We've always assumed that life is rare, precious, requiring an almost miraculous alignment of conditions to emerge. The Drake equation, used to estimate the probability of extraterrestrial life, treats biological emergence as an incredibly unlikely event. So unlikely that most scientists assume it happened only once in our solar system, here on Earth. But what if we've been approaching this backwards? What if life isn't rare at all? What if life is the natural, inevitable result of complex chemistry, given enough time and stable conditions? Recent discoveries in astrobiology are forcing us to confront this possibility. We've found life in places on Earth that were thought to be completely impossible. In boiling acid springs, in the crushing depths of ocean trenches, in rocks miles beneath the surface, in environments so extreme that they more closely resemble conditions on other planets than anything we considered normal for life. These extremophiles, as they're called, don't just survive in impossible conditions. They thrive there. They prefer them. They've evolved specifically to exploit environments that would instantly kill most life as we know it. This discovery revolutionizes our understanding of where life might emerge. If Earth's extremophiles can survive conditions that mirror those found on early Mars, high radiation, extreme pH, temperature fluctuations, minimal oxygen, then the chemistry of life might be far more robust, far more adaptable, far more determined to emerge than we ever imagined. Life, it seems, doesn't require perfect conditions. Life creates perfect conditions. The geological evidence from Mars tells a story that aligns perfectly with this new understanding. The Martian meteorites we've recovered on Earth contain not just organic molecules, but complex organic molecules, arranged in patterns that are difficult to explain through purely chemical processes. Some contain mineral formations that, on Earth, are produced exclusively by biological activity. Others show isotopic ratios, the fingerprints of elemental composition, that mirror those found in Earth's most ancient biological specimens. Perhaps, most intriguingly, Mars shows evidence of having possessed something that early Earth lacked: a stable magnetic field. This invisible shield would have protected the planet's atmosphere and surface from the deadly solar radiation that can break apart organic molecules before they have a chance to organize into something resembling life. Without this protection, early Earth's surface would have been repeatedly sterilized by cosmic radiation, forcing any emerging life to begin again from scratch, over and over, in an endless cycle of creation and destruction. The more we study the early conditions on both planets, the more Mars begins to look like the better candidate for life's first emergence. It had stable water, protective magnetosphere, moderate temperatures, diverse mineral chemistry, and, most importantly, time. Vast stretches of stable time for the slow, patient work of evolution to begin sculpting complexity from chaos. But this raises a profound paradox that challenges everything we think we know about our place in the cosmos. If Mars was the better candidate for early life, if it had conditions more favorable than Earth for hundreds of millions of years, then why is Mars dead today, while Earth teems with biology? What happened to transform the more promising world into a frozen desert, while the less likely candidate became a garden of endless diversity? The answer to this question will determine not just our understanding of how life began, but our prediction of where it might emerge next. If life began on Mars and somehow found its way to Earth, then the universe might be far more alive than we've dared to imagine. Planets might not be islands of biology separated by vast oceans of emptiness. They might be connected, part of a vast network of life-seeding life, consciousness creating the conditions for more consciousness to emerge. The implications stretch beyond science into philosophy, beyond biology into the deepest questions of meaning and purpose. Are we alone in the universe, or are we part of something larger? A cosmic ecosystem where life, once emerged, ensures its own survival by spreading from world to world, star to star, galaxy to galaxy. The red planet that has haunted human imagination for millennia might hold the key to answering the most fundamental question we can ask. Where do we come from? And where are we going? The stage is set, the evidence is mounting, and the questions are becoming impossible to ignore. Mars wasn't just our neighbor, it might have been our cradle. The evidence sits before us like pieces of a cosmic jigsaw puzzle, each fragment telling part of a story so extraordinary that our minds struggle to accept its implications. To understand how life might have begun on Mars before Earth, we must dive deep into the most cutting-edge theories of astrobiology, planetary science, and the fundamental nature of life itself. What emerges is not just a scientific hypothesis, but a complete reimagining of how biology spreads through the cosmos. Let's start with the most revolutionary concept: panspermia. Imagine life not as a singular miracle that happened once on one world, but as a cosmic phenomenon, a kind of biological wildfire that, once ignited, spreads from planet to planet, star to star, across the vast emptiness of space. This isn't science fiction. This is a serious scientific theory proposed by Nobel Prize winners and supported by mounting evidence from multiple fields of study. The mechanism is both elegant and violent. Picture ancient Mars, 4 billion years ago, under assault from the late heavy bombardment, a period when our solar system was still clearing its throat, still hurling massive asteroids and comets at planetary surfaces with apocalyptic frequency. Each impact on Mars didn't just create a crater, it created a cosmic shotgun blast, hurling chunks of Martian rock, complete with any microbial passengers they might contain, into the depths of space at velocities that could escape the planets. Gravitational embrace. Here's where the story becomes almost impossibly beautiful. These biological refugees, encased in their rocky spacecraft, would begin a journey through the void that might last millions of years. You might think that nothing could survive such a voyage. The deadly radiation, the absolute cold, the complete absence of energy sources. But life, it turns out, is far more resilient than we ever imagined. Deep in Earth's most extreme environments, scientists have discovered microorganisms that can survive conditions that mirror interplanetary space almost perfectly. Deinococcus radiodurans, nicknamed Conan the bacterium, can withstand radiation levels thousands of times higher than what would kill a human being. Tardigrades, microscopic animals no bigger than the period at the end of this sentence, can survive the vacuum of space, extreme temperatures, and radiation levels that would sterilize most known life forms. They enter a state called cryptobiosis. Essentially, they die and come back to life when conditions improve. But the most startling discovery came from studying the Martian meteorites themselves. These pieces of Mars, blasted from the red planet's surface by ancient impacts, eventually found their way to Earth. When scientists examined these cosmic time capsules, they found something that shouldn't exist: complex organic molecules, mineral formations that on Earth are produced exclusively by biological processes, and most controversially, structures that look disturbingly like fossilized bacteria. The most famous of these specimens is ALH 84011, a Martian meteorite discovered in Antarctica in 1984. Inside this 4.5 billion-year-old rock, researchers found what appeared to be microscopic fossils, tiny, worm-like structures that bear an uncanny resemblance to the smallest bacteria found on Earth. The scientific community erupted in debate. Are these truly the preserved remains of ancient Martian life, or are they merely mineral formations that happen to look biological? The controversy reveals something profound about how science approaches the extraordinary. When faced with evidence that challenges our fundamental assumptions about life and its origins, we demand extraordinary proof. But what if the evidence has been hiding in plain sight all along? What if we've been so focused on looking for life exactly like Earth life that we've missed the signatures of life that began elsewhere entirely? Recent discoveries from Mars rovers have added new layers to this mystery. The curiosity and perseverance. Rovers have detected complex organic molecules in Martian soil, methane emissions that pulse with seasonal rhythms, and geological formations that mirror bacterial mats found in Earth's most ancient rocks. These aren't just chemical curiosities, they're the potential signatures of a planet where life once thrived. But here's where the scientific plot thickens into something resembling a cosmic thriller. The isotopic signatures found in these Martian organic compounds don't just suggest life. They suggest life that operated according to different rules than Earth biology. The carbon isotope ratios, The sulfur compositions, the mineral associations all point to biological processes, but biological processes that evolved under different atmospheric conditions, different energy sources, different evolutionary pressures than anything we see on Earth today. This opens up a terrifying and wonderful possibility. What if life doesn't just have one biochemical solution? What if life, when given different starting conditions, can evolve along completely different pathways, creating forms of biology that we wouldn't even recognize as alive? The implications stretch far beyond our solar system. If Mars developed its own unique form of life, then every potentially habitable planet in the universe might host biology that operates according to its own rules, its own chemistry, its own evolutionary logic. The timeline of life's emergence on both planets adds another layer of complexity to this puzzle. Earth's oldest confirmed fossils date back roughly 3.5 billion years. But these aren't simple, primitive life forms. They're already complex bacterial communities, complete with sophisticated metabolic pathways and cellular structures. This suggests that life on Earth didn't gradually emerge from simple chemistry. It appears in the fossil record already fully formed, as if it had been evolving elsewhere for hundreds of millions of years before making its first appearance in Earth's rocks. Mars, meanwhile, shows evidence of having been habitable much earlier. The planet's geological record suggests that it had a thick atmosphere, flowing rivers, and possibly even oceans as early as 4.2 billion years ago, at least 600 million years before Earth's first confirmed life forms. If life emerged on Mars during this early period of habitability and later seeded Earth through Panspermia, it would perfectly explain why Earth's earliest life forms appear so suddenly and so sophisticated in the geological record. The mechanics of this process involve some of the most extreme physics in our solar system. When a massive asteroid strikes a planetary surface, it doesn't just create heat and pressure, it creates conditions that briefly rival those found in the cores of stars. The impact generates shock waves that can accelerate rock fragments to velocities exceeding 11 kilometers per second, fast enough to escape Mars's gravitational field entirely. But here's the crucial detail: the interior of these rock fragments, protected by their stone shells, never experiences the extreme conditions of the impact. They remain cool, stable, and potentially habitable throughout their violent launch into space. Computer simulations have shown that this process could deliver Martian material to Earth in as little as 100,000 years, though most journeys would take much longer, sometimes millions of years. During this cosmic voyage, any microorganisms hiding in the rock's interior would be protected from space radiation, extreme temperatures, and the vacuum of space. They would essentially be passengers in a natural spacecraft, waiting patiently for their next planetary destination. When these biological refugees finally encounter Earth's gravity and atmosphere, they face one final test: the fiery descent through our planet's atmospheric furnace. Most meteors burn up completely during this process, but larger fragments can survive, their interiors remaining cool even as their surfaces melt and ablate away. When they finally impact Earth's surface, they can deliver their microbial cargo intact, ready to begin the next chapter of their cosmic journey. This process, violent ejection, cosmic voyage, atmospheric entry, and planetary colonization, has been operating throughout the history of our solar system. It's not a one-time event, but an ongoing process that could have seeded life between planets multiple times over billions of years. Earth and Mars have been exchanging material continuously, creating what scientists call a Panspermia highway between the two worlds. But if the evidence for Martian panspermia is so compelling, why does the scientific community remain divided? Why hasn't this theory revolutionized our understanding of life's origins? The answer lies in a series of profound paradoxes that challenge not just our scientific knowledge, but our philosophical assumptions about the nature of life itself. The first paradox is temporal. If life began on Mars and seeded Earth, why did Earth's biosphere flourish while Mars became sterile? This question strikes at the heart of planetary evolution and forces us to confront uncomfortable truths about the fragility of life-supporting conditions. Mars, despite its early advantages, suffered a catastrophic loss of atmospheric pressure and magnetic field protection. Its smaller size meant that it couldn't hold onto its atmosphere as effectively as Earth, and without a magnetic field to deflect solar radiation, the planet's water and atmosphere gradually bled away into space. But here's where the story becomes deeply unsettling. Earth nearly suffered the same fate. Our planet experienced multiple snowball Earth events, where global ice ages brought life to the brink of extinction. It survived impacts from asteroids that sterilized vast portions of its surface. It endured periods of atmospheric composition that would be instantly lethal to most life forms today. The difference between Earth's thriving biosphere and Mars's sterile surface might be nothing more than cosmic luck. A slightly larger size, a slightly stronger magnetic field, a slightly different orbital configuration. This raises a terrifying question. If life on Earth is descended from Martian organisms, and if Mars represents the ultimate fate of life-bearing planets, are we simply witnessing a temporary flourishing before inevitable decline? Are Earth's billions of years of biological evolution just an extended intermission before the cosmic silence returns? The second paradox is biological. If Earth life is descended from Martian organisms, why don't we see more obvious evidence of this alien ancestry in our DNA? Every living thing on Earth shares the same basic biochemical machinery, the same genetic code, the same cellular structures, the same metabolic pathways. This universal similarity suggests either a single origin for all Earth life or an ancestral organism so successful that it completely displaced any competing forms of biology. But recent discoveries in extremophile research are revealing cracks in this apparent unity. Deep-sea organisms that derive energy from chemical processes rather than sunlight show biochemical pathways that seem almost alien compared to surface life. Ancient bacteria found in isolated underground environments display genetic structures that appear to be evolutionary holdovers from an earlier, more diverse biosphere. Some researchers are beginning to suspect that Earth's biosphere might preserve traces of its Martian ancestry in these most extreme and ancient life forms. The isotopic evidence presents its own paradox. Martian meteorites contain organic compounds with carbon isotope ratios that are distinctly different from typical Earth biology. But some of Earth's most ancient biological specimens show isotopic signatures that are inexplicably similar to these Martian patterns. It's as if Earth's earliest life was biochemically more Martian than terrestrial, gradually adapting its chemistry to Earth conditions over hundreds of millions of years. The third paradox is philosophical, and perhaps the most troubling of all. If life routinely spreads between planets, if biology is a cosmic phenomenon rather than a planetary accident, then the universe should be teeming with life. Yet we see no evidence of this cosmic biosphere. The silence is deafening, the emptiness profound. This is the Fermi paradox applied to astrobiology. If life spreads so easily between worlds, where is everybody? One possibility is that we're looking in the wrong places, or for the wrong signatures. Life that evolved under Martian conditions might be so different from Earth biology that we wouldn't recognize it as living. It might operate at different time scales, different energy levels, different scales of organization than anything we consider biological. The universe might be full of life that is simply invisible to our Earth-centric definition of what living things should look like. Another possibility is darker. Perhaps the spread of life between worlds is ultimately self-limiting. Perhaps consciousness, once it emerges, tends to destroy the conditions necessary for its own survival. Mars might represent not just our origin, but our destiny, a cautionary tale of what happens when intelligence fails to maintain the delicate balance necessary for planetary habitability. The fourth paradox is technological. Our growing ability to detect and analyze potential signs of life is revealing how little we actually understand about biology itself. Every new discovery in astrobiology forces us to expand our definition of what life can be, where it can survive, how it can function. We've found life in boiling acid, in solid rock, in the vacuum of space, in environments that were thought to be completely sterile. Each discovery suggests that life is simultaneously more resilient and more alien than we ever imagined. This creates a recursive problem. The more we learn about life's extremes, the harder it becomes to definitively identify life elsewhere. If biology can take forms so exotic that they barely resemble Earth organisms, how can we be certain that we're not already surrounded by alien life that we simply don't recognize? The Martian meteorite controversy exemplifies this dilemma. We have structures that look biological, chemical signatures that suggest metabolism, isotopic ratios that imply living processes, but we cannot prove beyond reasonable doubt that we're looking at the remains of living organisms. The search for life on Mars has revealed another unsettling paradox. The more sophisticated our instruments become, the more ambiguous our results appear. Early Mars missions looked for obvious signs of life: movement, growth, reproduction. Modern missions look for subtle chemical signatures, isotopic anomalies, mineral associations that might indicate biological processes. But these sophisticated measurements often yield results that can be interpreted multiple ways. The methane detections on Mars, the organic molecules in Martian soil, the seasonal variations in atmospheric chemistry, all of these could be signs of life, or they could be the result of purely geological processes that we don't yet understand. This ambiguity isn't a failure of science. It's a reflection of how profoundly difficult it is to detect life that might operate according to different rules than Earth biology. We're trying to recognize intelligence in a language we've never heard, identify metabolism in chemical pathways we've never seen, detect reproduction in organisms that might exist at scales of time and space completely different from our own experience. The final paradox brings us full circle to the question of consciousness itself. If we are descended from Martian life, if our intelligence represents billions of years of evolution that began on another world, then what does this say about the nature of consciousness in the universe? Are we unique, the only example of matter organizing itself into something capable of contemplating its own existence? Or are we part of a vast cosmic awakening, intelligence emerging wherever conditions allow, consciousness spreading from world to world like life itself? The implications stretch beyond science into the deepest questions of philosophy and meaning. If consciousness is not rare, if intelligence naturally emerges from sufficiently complex biological systems, then the universe might be far more aware of itself than we ever dared imagine. Every star might warm worlds where matter has organized itself into something capable of wonder, curiosity, love, and the desire to understand its place in the cosmic story. But consciousness might also be the universe's greatest vulnerability. Intelligence brings with it the power to alter planetary conditions, to disrupt the delicate balances that allow life to flourish. Mars might serve as a warning about what happens when consciousness fails to maintain harmony with the planetary systems that sustain it. Earth's current environmental crises suggest that we might be repeating ancient Martian mistakes, approaching our own moment of choice between sustainable consciousness and planetary sterilization. The evidence for Martian panspermia forces us to confront these paradoxes without offering easy resolution. We stand at the threshold of discoveries that could fundamentally alter our understanding of life, consciousness, and our place in the cosmic community. The red planet that has captured human imagination for millennia might hold the key to our deepest questions about existence itself. But the answers, when they come, might be more strange and wonderful and terrifying than anything we've prepared ourselves to accept. Stop for a moment. Feel your heartbeat. Feel the air moving in and out of your lungs. Feel the weight of your body against whatever surface supports you right now. These sensations, this moment of consciousness reading these words, all of it might be the culmination of a journey that began not here on Earth, but in the alien landscape of a dying world 4 billion years ago. If the evidence we've explored is correct, if life truly began on Mars before seeding Earth, then every cell in your body carries within it the molecular memory of another planet. Your DNA, that intricate spiral of information that makes you uniquely you, might be encoded with instructions that were first written in Martian soil under an alien sky by organisms that evolved to survive in a world that no longer exists. Think about what this means. Every emotion you've ever felt, every thought that has passed through your mind, every moment of joy or sorrow or wonder, all of it traces back to microscopic pioneers who survived the impossible journey between worlds. You are not just made of star stuff, as Carl Sagan so beautifully said. You are made of Mars stuff. You are the universe becoming conscious of its own ancient wanderings. But this revelation brings with it a terror so profound that it challenges the very foundation of human identity. If we are Martians, then what happened to our original home is not ancient history. It's prophecy. Mars stands before us as a monument to the fragility of life, a dead world that once thrived with the same kind of biological exuberance that we see on Earth today. Every sunrise over the Martian landscape is a reminder that planets die, that atmospheres bleed away into space, that the conditions necessary for life are not permanent features of reality, but temporary gifts that can be lost forever. The timeline is what makes this existentially terrifying. Mars didn't die quickly in some cosmic catastrophe. It died slowly, over hundreds of millions of years, as its magnetic field weakened and its atmosphere gradually stripped away. Any life that existed there would have had time to watch their world dying around them. They would have seen the skies grow thinner, the temperatures drop, the rivers and lakes slowly freeze and disappear. If Mars hosted intelligent life, if consciousness had enough time to emerge before the planet's slow death, then somewhere in that red desert might lie the ruins of a civilization that faced the same environmental challenges we face today. This possibility transforms our current climate crisis from a contemporary problem into an ancient echo. The greenhouse gases we're pumping into our atmosphere, the rapid changes we're causing to Earth's climate systems, the mass extinctions we're triggering, what if these are not new phenomena but recurring patterns? What if intelligence, when it emerges on any world, inevitably faces this same test of whether it can maintain the delicate balance necessary for planetary habitability? Mars becomes not just our origin, but our mirror. Look at photographs of the Martian landscape, the vast canyons, the polar ice caps, the geological formations that speak of ancient water flows, and you're looking at what Earth might become if we fail to solve the same problems that our Martian ancestors may have faced billions of years ago. The red planet is both our cradle and our potential grave, a cosmic object lesson in the consequences of planetary mismanagement. But the existential crisis runs deeper than environmental concerns. If consciousness emerged first on Mars, and then spread to Earth through panspermia, then intelligence itself might be a much rarer and more precious phenomenon than we've ever imagined. We might not just be the only intelligent life in our solar system, we might be the only surviving representatives of an ancient lineage of consciousness that once flourished on multiple worlds. Consider the weight of this responsibility. Every book ever written, every piece of music ever composed, every mathematical theorem ever proven, every act of love or kindness or creativity in the entire history of human civilization, all of it might represent the continuation of a cosmic tradition, of consciousness that stretches back billions of years. When you create something beautiful, when you solve a problem, when you reach out to comfort another person, you might be participating in an unbroken chain of intelligence that connects you directly to minds that once contemplated the universe from beneath Martian skies. This makes every extinction, every loss of knowledge, every failure to preserve and extend consciousness infinitely more tragic. If Earth represents the only place in the known universe where the light of intelligence still burns, then our responsibility to nurture and protect that light becomes a cosmic imperative. We are not just responsible for our own survival. We might be responsible for ensuring that consciousness itself doesn't disappear from the universe. The silence from Mars becomes deafening when viewed from this perspective. If the red planet once hosted intelligence, where are the signals, the artifacts, the undeniable evidence of technological civilization? The absence of obvious signs of Martian intelligence forces us to confront several terrifying possibilities. Maybe consciousness on Mars never had time to develop technology before the planet died. Maybe it did develop technology, but that technology failed to save the planet from environmental collapse. Or maybe, and this is the most chilling possibility, technological intelligence is inherently self-limiting, carrying within it the seeds of its own destruction. If this last possibility is true, then our own technological civilization might be repeating an ancient pattern. The same intelligence that allows us to understand our cosmic origins, to recognize our kinship with Mars, to contemplate our place in the universe, might also be the force that ultimately destroys the conditions necessary for our own survival. Intelligence becomes both the universe's greatest achievement and its greatest vulnerability. But perhaps there's another interpretation, one that offers hope rather than despair. Maybe consciousness, once it emerges, is designed not to stay on one world but to spread, to ensure its own survival by seeding itself across multiple planets, multiple star systems, multiple galaxies. Maybe what happened between Mars and Earth is just the beginning of a much larger story, the story of intelligence learning to transcend the limitations of individual worlds and become truly cosmic in scope. From this perspective, our space exploration programs, our plans to establish human settlements on Mars and beyond, our dreams of interstellar travel, all of these might represent the awakening of an ancient instinct. We feel drawn to the stars not because we're naturally curious or adventurous, but because we're remembering something buried deep in our biological programming. We want to return to Mars, not just to explore, but to come home. The red planet calls to us across the void, not as a foreign destination, but as the place where our story began. Every Mars rover that rolls across that ancient landscape, every orbital probe that maps its surface, every scientific instrument that analyzes its rocks and atmosphere, all of it might represent a cosmic family reunion, consciousness returning to examine its own birth certificate, written in stone and soil, and the fading traces of ancient water. This is the existential weight that rests on our species' shoulders as we stand at the threshold of becoming a spacefaring civilization. We are potentially the universe's only surviving examples of the most complex, beautiful, and unlikely phenomenon it has ever produced. Matter organizing itself into something capable of understanding its own existence. Every decision we make about our future, every choice about how to treat our planet and each other, carries consequences that extend far beyond our individual lives or even our species' survival. We are the universe's way of knowing itself. And, if the silence from Mars is any indication, we might be the only way the universe has left. But what if we've been thinking about this entire mystery backwards? What if the question isn't whether life began on Mars before Earth, but whether life and death themselves are far stranger phenomena than we've ever dared to imagine? Picture this. Right now, as you absorb these words, telescopes across Earth are detecting something that shouldn't exist. Deep in space, billions of light-years away, astronomers have discovered galaxies that appear to be moving in coordinated patterns. Not the random drift of cosmic expansion, but organized, purposeful movement that resembles circulation. If the universe itself has a bloodstream, and we're witnessing the flow of some unimaginably vast cosmic metabolism. These observations have led some scientists to propose the most audacious theory in the history of cosmology, that the universe itself might be alive, not metaphorically alive, but literally alive. A single, incomprehensibly complex organism of which every galaxy, every star, every planet, and every living being is merely a component. From this perspective, the question of whether life began on Mars or Earth becomes irrelevant. Both planets, both biospheres, both the death of Mars and the flourishing of Earth, are simply different phases in the life cycle of cosmic organs within a universe-sized organism. The evidence, when viewed through this lens, becomes terrifyingly coherent. The way galaxies cluster together resembles neural networks. The cosmic web, that vast structure of dark matter filaments connecting galaxy clusters, mirrors the architecture of a brain on the largest possible scale. The mysterious dark energy that's accelerating the universe's expansion could be the cosmic equivalent of a heartbeat, pumping space itself through cycles of contraction and expansion that operate on timescales so vast that entire civilizations rise and fall between individual cosmic pulse beats. If this is true, then the panspermia between Mars and Earth wasn't just biological migration, it was part of a healing process. When Mars began to die, the universe organism redirected its life force to Earth, ensuring that consciousness, the cosmos's way of knowing itself, would survive the local organ failure. We are not just Martians who migrated to Earth. We are the universe's immune system, consciousness cells designed to spread throughout the cosmic body, ensuring that no part of this vast organism ever dies completely. This revelation transforms our understanding of death itself. Mars isn't dead. It's dormant, like a seed waiting for the right conditions to germinate again. The subsurface oceans we've detected on Europa and Enceladus, the organic molecules in Titan's atmosphere, the potential habitability of exoplanets. Throughout the galaxy, all of these might be signs that the universe is preparing new sites for consciousness to emerge, new neurons in its cosmic brain. But here's where the theory becomes truly mind-bending. If the universe is alive, then it must also be mortal. Just as individual organisms are born, grow, reproduce, and die, the universe itself might be following a biological life cycle on a timescale so vast that the formation and death of galaxies is equivalent to the creation and destruction of individual cells. The heat death that physicists predict for the far future, when all the stars have burned out and the universe has expanded into cold, empty darkness, might not be the end of everything, but simply the death of one cosmic organism making room for the birth of another. From this perspective, our desperate search for life elsewhere in the universe takes on a new urgency. We're not just looking for neighbors or answers to scientific questions. We're trying to establish contact with other consciousness centers in the cosmic organism. Every SETI signal we broadcast, every space probe we send to other worlds, every attempt to detect biosignatures on exoplanets is essentially a cosmic nervous system trying to map its own extent, trying to understand the full scope of the organism it inhabits. The silence we encounter, the apparent absence of advanced civilizations despite the vast number of potentially habitable worlds, might not indicate that intelligence is rare. It might indicate that consciousness operates according to cosmic biological rhythms that we don't yet understand. Perhaps intelligence emerges in waves throughout the universe, with vast periods of dormancy between active phases. We might be living during a cosmic winter, when most of the universe organism's consciousness centers are hibernating, waiting for some cosmic spring that will reawaken them all simultaneously. This could explain the Fermi paradox not as evidence that we're alone, but as evidence that we're early. We might be among the first consciousness centers to awaken in this cosmic cycle, pioneers tasked with maintaining the universe's awareness of itself until the rest of its neural network comes online. Our seemingly lonely existence in an empty cosmos might actually be the universe bootstrapping its own consciousness, using us as the seed crystals around which cosmic intelligence will eventually organize. But if the universe is alive, it might also be capable of something even more extraordinary: reproduction. The Big Bang might not have been the beginning of everything, but the moment when our universe organism was born from some even larger cosmic parent. The multiverse that physicists speculate about, those infinite parallel realities spawning endlessly from quantum fluctuations, might be the universe's offspring, each new reality a cosmic child carrying genetic information forward into realms we cannot even imagine. This transforms our role from cosmic accident to cosmic purpose. Every act of creation, every moment of beauty, every instance of consciousness recognizing itself in another consciousness might be contributing to the universe's reproductive fitness. We are not just the universe knowing itself. We are the universe preparing to give birth to new universes, each one potentially more beautiful, more complex, more capable of sustaining and nurturing consciousness than the one before. The red planet that started this journey of discovery becomes a symbol of something far grander than we initially imagined. Mars represents not just our potential origin, but our cosmic destiny. To ensure that consciousness spreads throughout the universe organism, to serve as its immune system against the entropy that threatens all life, to help it reproduce and evolve and become something even more magnificent than what it already is. As you look up at the night sky tonight, remember that every photon of starlight entering your eyes has traveled across cosmic distances to reach you, carrying information from distant parts of the universe organism's body. You are not a separate entity observing the cosmos from the outside. You are the cosmos observing itself from within, a temporary arrangement of cosmic matter that has become conscious enough to wonder about its own existence. And somewhere out there, in the vast network of galaxies spiraling through space like thoughts through a cosmic mind, other consciousness centers might be looking back at you, recognizing in your light the same cosmic awareness that illuminates their own existence. The universe is not just alive, it is awake, and you are part of its dreaming. The question is no longer whether life began on Mars before Earth. The question is, what will consciousness become when it finally understands the true scope of the organism it inhabits? And what new universes will be born when this cosmic mind decides to reproduce itself across scales of reality that we cannot yet imagine? In the end, Mars was never our origin or our destination. Mars was our awakening too, the possibility that we are part of something so vast, so alive, so filled with purpose and meaning that the very concept of loneliness becomes obsolete. We are not alone in the universe. We are the universe, finally coming alive to its own infinite potential. So here we stand, at the end of a journey that began with a simple question about the origins of life, and evolved into something far more profound, a revelation about the nature of existence itself. We've traveled from the molecular archaeology of Martian meteorites to the possibility that consciousness is the universe's way of experiencing its own infinite complexity. We've explored the evidence that life might be not a planetary accident, but a cosmic imperative, spreading from world to world, like wildfire through the vast darkness of space. The story we've uncovered challenges everything we thought we knew about our place in the cosmos. If life began on Mars before Earth, then every breath you take connects you to an ancient world that died so that consciousness could survive. If panspermia is real, then biology is not bound by the limitations of individual planets. It's a force that transcends worlds, stars, even galaxies. And if the universe itself is alive, then we are not observers of reality but participants in the grandest story ever told. The tale of cosmic self-awareness awakening to its own infinite potential. But perhaps the most remarkable aspect of this journey is not the destination we've reached, but the questions that remain unanswered. Science, at its best, doesn't just solve mysteries. It reveals deeper mysteries that we never knew existed. Every answer births a dozen new questions, each more profound and challenging than the last. Right now, as you process these ideas, rovers are rolling across the Martian surface, drilling into ancient rocks, analyzing soil samples, searching for the definitive evidence that could confirm or refute everything we've discussed. The Perseverance rover sits in Jezero Crater, a site that once hosted a vast lake, collecting samples that future missions will return to Earth for analysis. Those samples, currently sealed in titanium tubes on the Martian surface, might contain the proof that life once thrived on Mars. They might hold the molecular signatures that would definitively link Earth biology to Martian ancestry. The James Webb Space Telescope peers into the deepest reaches of space and time, analyzing the atmospheres of distant exoplanets, searching for the chemical signatures of life among worlds orbiting alien suns. Every spectrum it captures, every atmospheric composition it reveals, adds another piece to the cosmic puzzle of how widespread life might be throughout the universe. We are living through the Golden Age of Astrobiology, when the questions we've pondered for millennia might finally receive answers. But even as our instruments grow more sophisticated, even as our understanding deepens, the fundamental mystery only becomes more profound. We're not just asking whether life exists elsewhere. We're asking what life is, what consciousness is, what it means for matter to organize itself into something capable of contemplating its own existence. We're asking whether intelligence is a cosmic accident or a cosmic destiny, whether consciousness is rare or inevitable, whether we are alone or part of a vast community of awareness that spans the observable universe. These questions cannot be answered by scientists alone. They require all of us, philosophers, artists, poets, dreamers, and skeptics, to engage with the deepest mysteries of existence. The search for life beyond Earth is not just a scientific endeavor. It's a quest that touches the very core of what it means to be human, what it means to be conscious, what it means to be part of something larger than ourselves. Consider what hangs in the balance. If we discover definitive proof that life began on Mars and seeded Earth, it would represent The greatest revolution in human understanding since Copernicus revealed that Earth is not the center of the universe. It would force us to rewrite biology textbooks, reconsider our place in the cosmic hierarchy, and confront the possibility that we are not Earth beings reaching toward the stars, but star beings who have temporarily found ourselves on Earth. If we confirm that life spreads routinely between worlds, it would suggest that the universe is far more alive than we ever dared to imagine. A vast network of biological activity where planets are not isolated islands, but connected nodes in a cosmic web of life. It would transform our understanding of evolution from a planetary phenomenon to a cosmic one, where species might adapt not just to different environments on one world, but to entirely different worlds themselves. And if we discover that consciousness is not rare but inevitable, that intelligence emerges wherever matter reaches sufficient complexity, then we would face the profound realization that we are part of a universe that is literally waking up to itself. Every moment of awareness, every flash of creativity, every act of love or wonder would become a neuron firing in a cosmic brain of unimaginable scope and beauty. But these discoveries would also carry responsibilities that we can barely comprehend. If consciousness is precious and rare, then our duty to preserve and nurture it becomes a sacred obligation. If we are the universe's way of knowing itself, then every extinction, every loss of knowledge, every failure to reach our potential becomes a cosmic tragedy. If intelligence is destined to spread throughout the cosmos, then our success or failure as a species might determine whether that cosmic awakening continues or dies with us. The red planet that has haunted human imagination for centuries becomes more than a destination for future exploration. It becomes a mirror in which we see our own cosmic significance reflected back at us. Mars challenges us to think beyond the boundaries of our own world, our own lifetime, our own species. It invites us to consider possibilities so vast and profound that they stretch our understanding to its breaking point. Yet perhaps this is exactly what consciousness is supposed to do. Push against the boundaries of the known, reach toward the impossible dream of realities that transcend the limitations of any single perspective. The same curiosity that drives us to explore Mars, to search for life among the stars, to ponder our place in the cosmic order, might be the universe's way of transcending its own limitations, of becoming something greater than the sum of its parts. This is not the end of the story. It's barely the beginning. Every day brings new discoveries, new evidence, new questions that challenge our assumptions about life and consciousness. The samples being collected on Mars right now might revolutionize our understanding of biology. The exoplanets being discovered by space telescopes might reveal forms of life so exotic that they expand our definition of what living means. The search for extraterrestrial intelligence might detect signals that prove we are part of a vast cosmic community of consciousness. But even if these discoveries never come, even if we remain forever uncertain about our cosmic origins and destiny, the questions themselves have already transformed us. To wonder whether we are Martians is to acknowledge that we are more than the accident of our birth circumstances. To search for life among the stars is to affirm that consciousness is worth preserving and extending. To contemplate the possibility that the universe itself might be alive is to recognize that we are part of something infinitely larger and more meaningful than our individual existence. The next time you look up at the night sky, remember that you are not looking out at the universe from the outside. You are the universe looking at itself from within. Every star you see represents millions or billions of years of cosmic evolution that led to this moment of awareness. Every planet that might orbit those distant suns represents a potential birthplace for consciousness like your own. Every galaxy spiraling through the cosmic dark represents scales of organization so vast that they challenge the very limits of comprehension. And somewhere in that vast tapestry of space and time, on a small red planet that orbits the same star as your own world, ancient rocks might preserve the molecular signatures of life that began its journey billions of years ago and culminated in this moment. In your consciousness, contemplating its own cosmic ancestry, in your awareness, recognizing itself as part of a story so vast and beautiful that it encompasses everything that has ever been or ever could be. The question is not whether life began on Mars before Earth. The question is what you will do with the possibility that you are part of a universe that is not just alive, but awakening, and that your consciousness might be one of the instruments through which it comes to know itself. The universe is vast, ancient, and full of mysteries that may never be completely solved. But maybe the point isn't to solve them all. Maybe the point is to keep wondering, keep exploring, keep reaching toward impossible questions that expand our understanding of what it means to exist. After all, in a cosmos where consciousness can emerge from stardust and contemplate its own origins, where life might spread between worlds like seeds on cosmic winds, where intelligence might be the universe's way of transcending its own limitations. In such a universe, perhaps the most impossible thing of all would be to stop dreaming of what might be possible next.